Alright, so we're going to talk about circles and how completing the square relates to circles, squares and circles. You'd be surprised. Anyways, so this is a question from the trigonometry regions. It asks what the equation of this circle is, and if you recall from geometry that a circle can be determined by knowing its center and by knowing its center and its radius. So this point, we can see what that is. So this is the radius. We'll call that R. And the center, in this case, is 3, 3, -4. Okay, so we need those two things, and it plugs into the center radius formula of a circle, which is x minus h squared plus y minus k squared equals r squared, and this is where h and k represent the center of the circle, and r is the radius. So firstly, since we know the center in this case is 3, -4, we can say that the equation of the circle is x minus 3 squared. This is the negative here. And y plus 4 squared, again because of the negative, the sign is opposite, is equal to r squared. Now before we write down what r squared is, we have to actually determine the value of r squared, and looking at this picture we can see a right triangle here forming. So let's try and use that. Alright, so this has a vertical distance of 4 and a horizontal distance of 1. So this is a right triangle whose sides measure 4 and 1. So 4 squared plus 1 squared equals r squared. Alright, so 16 plus 1 equals r squared. So 17 is equal to r squared. So that's all we need at the moment for the sake of completing the equation of the circle, because this is r squared. But that does mean that the radius is equal to radical 17. Okay, so that's the equation of the circle. And this is called, so yeah, radius here is radical 17. So, in this circle, this is center radius form. But there's another form of a circle called standard form. As with most graphable equations, they have a standard form. It's usually where you have all terms simplified, whereas these clearly can be squared and become less, can become more simple. So I'm going to erase this, and we're going to look at what standard form looks like. Okay, so to go to standard form, we're going to square x minus 3, which, if you recall, means to multiply x minus 3 by itself. X squared minus 3x plus 9. So that's x squared minus 6x plus 9. And we can do the same thing for y plus 4 squared. That's y plus 4 and y plus 4. So that's y squared plus 4y plus 4y plus 16. So that is this, 8y plus 16 equals 17. And standard form would be to have the two square terms, the two linear terms, equals a constant term. So rearranging this a little, we get x squared plus y squared minus 6x plus 8y plus 9 and 16 is 25. so if we subtract 25 from both sides, we get a standard form of this circle. Uh, 17 minus 25 is 8. Negative 8. So if you were given this, you'd need to know this was a circle. And the key to knowing that this is a circle is noticing that there is an x squared term and a y squared term. If you have both, your equation is either a circle or an ellipse, if they're on the same side, with a plus in between them, and they're both having the same sides. So this is standard form of a circle. If we had to write that down, standard form would be x squared plus y squared minus plus. So yeah, let's actually revise this slightly. That would be ax squared plus ay squared plus bx plus cy equals d. So these should be the same to be a circle. If these were different, this would actually be an ellipse, or a hyperbola, depending if these signs are different. Alright, let's take a look at an example. Alright, so we're given O equals 0. Perhaps I should revise that. Alright, so let's revise that. Easy to revise. Plus d equals 0. And in this case we would actually, instead of having subtracted the 25 from both sides, we would have subtracted 17 from both sides and obtained plus 8 equals 0. Okay, so let's take a look at an example. Alright, so we're given a circle in standard form. In order to see the center and radius, we'd have to graph that. I have GeoGebra open, so we can take a look at what that looks like. Alright, so let's see the equation. And I'll enter it into the toolbar down below. So we have x squared plus y squared minus 8x plus 2y plus 8 is equal to 0. So that becomes this equation, x minus 4 squared plus y plus 1 squared equals 9. So that's a circle with a center at 4, negative 1. So yeah, with a center at 4, negative 1, and a radius of 3. So let's see how we can do that without a calculator or a computer. Firstly, we want to put the x terms together. So this will become x squared minus 8x plus y squared plus 2y. And I'm going to move the 8 to the other side afterwards. Not yet. Alright. So we're going to complete the square, and there are two parts to complete. We're going to complete this, and we're going to complete this. Alright, so the term that completes this square is half of the 8 squared, so that's 4 squared, or 16. So we're going to add 16 to both sides. Actually, yeah, let me move the 8 before we do that. So moving the 8 to the other side, this will become equals negative 8. Alright, so the term that completes this square is 16, because it's 1/2 of the 8 squared. And the term that completes this is 1, okay, because it's 1/2 of 2 squared. If you've forgotten, this is what we have here. We have x squared minus 4x minus 4x, which makes these both -4, which makes the completing square term 16. Okay, same thing goes for the other terms. We have y squared, we have y here, y here. This is going to be 1 because that's y plus 1 and y plus 1. So the term that completes the square is 1, and for this 16. So that'll become x squared minus 8x. Let's leave a blank space for that 16. Y squared plus 2y equals, oh wait, I need a blank space for that 1, equals -8. So we're going to add 16 to both sides, and add 1 to both sides as well. Now these three terms become x minus 4 squared, as we saw in GeoGebra. These three terms become y plus 1 squared. And that will equal, that's 16 minus 8 is 8, plus 1 is 9. So that's a circle with center 4, -1, and radius 3. So that would be choice B. Let's take a look at another example. This one looks more complex. You'll notice that these have the same values, therefore this is a circle. If they were different, it would have been an ellipse or a hyperbola, depending on whether their signs were the same. So first thing we can do is remove those 3's entirely by dividing everything by 3. Alright, so we get x squared plus y squared plus 12x plus, oh, sorry, not 12x, 4x minus 8y plus 3 goes in here once with a remainder of 2, 27, 3 goes into 27, 9 times equals 0. And now we're going to just shift everything around a little to make it in a more appropriate form for this. That's going to be x squared. Put the 4x next to that. Leave a space to complete the square. We need the y squared then. I'm going to move the 8y here. And we're going to move the 9 to the other side. So these terms are getting rearranged. So this switched places with that. This I'm going to move over here. Okay, so what completes this square? Just like before, we can make the square. I don't think that's worth the time. So it's going to be half of this squared, which is 4. And we're going to take half of this and square that, so that's 16. Whatever we do to one side, we do to both. So this needs a 4 and a 16. So that'll give us x squared plus 4x plus 4 plus y squared minus 8y plus 16 equals, that's 11. Alright, so these three terms will become x plus 2 squared, and these will become y minus 4 squared. So that means this has a center at -2, 4, and a radius of radical 11. Alright, one last example, just because it comes up on the regions. We're given the center of a circle, which is 3, -4, and a point on the circle. So 6, 5 would be up here somewhere. Alright, so this is a circle centered here. Let's make that a color we can see. Alright, let's find this distance. So to go from 3 to 6, that would be a distance of 3. So to go from -4 to 5 is a distance of 9. So 3 squared plus 9 squared equals r squared, the radius.